Welcome to 2.4 complex numbers. Let's go ahead and get started. Definition of a complex number. Before we get into there, you're going to see this I pop up, and I know that some of you have talked about complex numbers before. Here's the story on complex numbers. You've got a real number part A and an imaginary part, and the first question you should have is, why in the world would we ever work with something called imaginary numbers? Well, among a couple other things, they are involved in electrical circuits. So there's a lot of mathematics that never considers complex numbers, but there is some out there if you specialize in some areas. So anyway, this I, you don't want to think of that as a variable. I is the square root of -1, which seems strange because, of course, we don't have, I guess, real numbers where we can have the square root of a negative, but square root of -1 is I. Therefore, something like the square root of -4 could be considered the square root of -1 times 4, or I times 2, square root of 4, 2, or 2I. Also worth noting, I squared is -1. So those are some things to keep in mind that are kind of the foundation of everything we're doing here. So anyway, we won't spend a whole lot of time, in fact this entire year, dealing with imaginary numbers, but they definitely have some actual real-world applications. So anyway, if A and B are real numbers, then the number A plus BI is considered a complex number. It's said to have a real part and an imaginary part, and this is written in standard form. If B is 0, that absorbs the I and the number is strictly real. If A is 0, the number is strictly pure imaginary or imaginary, but A plus BI is called complex number. Okay, in order for two complex numbers to be equal, the real part, A and C, have to be equal, and the imaginary part have to be equal. If A doesn't equal C, there's nothing B can be and D can be to make those things equal. And here's the great thing about imaginary numbers to work with. If we're to add two imaginary numbers, it's exactly what you would think we would do. We just add the real parts and we add the imaginary parts, and you can see we sort of factored an I out here, and subtracting them, this would be A minus the C, and BI minus the DI, factor the I out. And here you go, this we kind of looked at up above. Principal square root of a negative number. This is kind of strange, but consider A to be a positive number. Then negative A would be a negative number. You can treat it like -1. And if we take -1 out as I, and you got to be careful here, because a lot of times people write this square root A, I, and it's like you kind of leave that I hanging, like, is it under the radical, is it not under the radical? It most definitely should be not under the radical. A lot of times I would write it as I square root of A, so the reader isn't left in the dark on that. Clearly they've done a nice job here, but I would really exaggerate that space, because that I kind of tends to sneak underneath that radical, and you don't want to leave any doubt in the viewer, especially, or in the grader, in the grader's perspective. Okay, so with that, you're going to find out your calculator does a lot of this work for you, as far as adding, subtracting, multiplying, dividing with imaginary numbers. But doing it by hand is not bad at all. So here we go. Find real numbers A and B such that the equation is true. In order for this to be true, then A, the real part, has to equal 12, and BI, the imaginary part, has to equal 5I. Therefore, A is 12 and B is 5, and yes, it's that easy. Okay, our real part, A plus 6, must equal our real part, 6, so A must be 0. Our imaginary part, 2BI, must equal -I, or -1 times I. Therefore, 2b must equal -1 b must be negative 1/2. And that is it. Okay, write the complex number in a standard form. This is 7 minus the square root of a negative is I. The square root of 25 is 5, so this is just 5i. Well, negative 3, this is purely real. To write it in standard form of a complex number, it needs to look like this, a plus bi. So standard form would be negative 3 plus 0 times I squared is negative 1. So we end up with 2 times negative 1, negative 2 minus 6i. Okay, here we have negative I minus, I can't do anything with the 23, but the negative, this would be square root of 23 times I squared. That is negative I minus square root of 23 squared is 23. I squared is negative 1. And so we get negative 23 times negative 1, positive 23, and a minus I, and that's in standard form. And this one's a little bit sneaky, but clearly we're going to have an I here. This would be square root 0.0004i, and you'd have to go back to when you learned to write with decimals and how you add zeros on. If you absolutely had to and didn't catch this, we could do this on our calculator. We could go second square root 0.0004. But if you give some thought to that, you may be able to come up with the correct answer to this. I mean, the 4 implies kind of a 2 in there, and we need 4 decimal points. So 0.02. Oh, so this is just 0.02i in standard form. That would be 0 plus 0.02i. Okay. So here's the real deal with working with imaginary numbers. You can really treat I like it's a variable. You just would never leave a square, like an I squared or an I to the third or an I to the fourth. That's simplifiable. But if you just have plain old I's, just treat it like it's an X. Also, you will never have a negative within a square root. So if I'm just treating this like X's, I would just go, well, this is 11 minus 2i, distribute plus 3 minus 6i, and I get 11 plus 3, 14, negative 2 minus 6i, minus 8i, and I'm done. The only thing that the I really comes into play is when there's a square root of a negative, or when there's an exponent attached to the I. So pretty straightforward here. Real part 7 plus real part 3, 10. Imaginary 6 plus imaginary 12, 18i. And sure, they can try to make it a little bit more challenging for us and give us fractions. And again, it won't matter to me if you go to calculator on this, but these have a common denominator at 12 times 3 on 3, 9 twelfths, times 2 on 2, minus 10 twelfths. These have a common denominator of 30 times 6 on 6, plus 42 thirtieths I, minus negative, plus, going to 30 times 5 on 5, 5 thirtieths I, for final answer, negative 1/12 real, and 42 plus 5 plus 47 thirtieths I. Okay, I'm going to distribute the negative and get that problem out of the way. Distribute the negatives, and we have 3.7 positive plus 12.8i. Distribute the negative, minus 6.1. Distribute the negative, plus 16.3i. 3.7 minus 6.1, that's going to be negative 2.4. And 12.8 plus is going to be 28 plus 1.1, 29.1i. You want calculator support? That's fine. Trust me on this one. You're not going to have a whole lot of computational challenges dealing with. I'm not going to give you nasty fractions or anything that you have to work with. Not that we couldn't do that, but I'm interested, can you work with I at this time? So should be a pretty quick page for you. Please let me know what I can help with.